So, I think we are ready to go, if you are. We just have to let people in. Thank you. And you're already here, so I don't even know what I'm doing here. But next up is Stefan and Michael from Stretch Connect, and they will tell you a little about how to get ready for AI machine learning and analytics, and also how to get there. But take it away. Thank you.
All right. Thank you.
Thank you.
All right, so let's see. We are going to switch. Actually, let's start here. So, yeah, my name is Stefan. Nice to see you all here. I've been with Stretch Connect for about 9 months now. Prior to that, I spent almost a decade and a half at Qlik, actually, in various positions. So I'm pretty comfortable with Qlik stuff. So I do BI architecture at Stretch Connect, which is interesting in the field of data today. And Michael?
Yeah, I'm Michael, partner at Stretch Connect. I've been with the Stretch for 6 years. Before that, I've done some management consulting, also done some startup companies, and done some satellite development. So I've done quite a bit of stuff. Now we're doing data analytics. So, yeah.
All right, so we are going to talk about getting data ready for analytics and AI, ML. And when I saw this topic pop up on the list of presentations, and I was suggested, or if I actually volunteered, I don't remember, I was like, oh wow, that's a pretty big topic. So Michael and I agreed on doing this in a story kind of fashion, and we're actually going to do it backwards. So we're not going to show too many slides. We're going to go pretty technical on this one, so please try to. We hope you like that. And what we're going to do is we're going to talk a little bit about why we actually need to care so much about this area, about these stuff. We can't do this left-handedly, and we want to kind of elaborate on why. We're going to talk a little bit about what we need, obviously, tooling, strategies, thinking, ways of thinking, and also how do we derive value out of this, and where do we actually get the thinking from to actually get there. How do we solve it? We're obviously going to show how to do it. Michael is going to run a couple of pretty cool demos, and I will run one. And can we achieve with this with Qlik and talent? So, if you're paying attention to the AI and data space today, or the data space historically, it's pretty wild. Like, there's a lot of tools out there. There is a lot of ways to do stuff. A lot of emerging technology has been for a few years. Cloud data warehousing has really hit it off, obviously. This puts immense pressure on organizations to try and understand, what stack to choose, what to do, how to deal with them. And AI and ML is doing the same thing right now. It's happening everywhere. It's being introduced in every part of the organization, and it's going very fast. Everybody wants to jump on this train. And I'm not sure, and Sebastian, now I have the microphone, so you can't stop me, but I'm not sure that everybody knows why they actually want to do this. So I think that value is really important, which is something we're going to talk about. Why do we actually want to do this? Again, what Dan said in the beginning here is that we can't do lockdown as well. With the scattered landscape of data and AI and ML and the emergence of all these tools, we can't stay in one lane. There has to be an openness to systems coexisting in different ways. And so we're hoping to show how we can do that as well. So, yeah.
Yeah. And if you're looking at actually what the current state is and what we actually need from that. So we need for our data, for the training and integration. So we actually need to pull the data out of our systems, and we need to make it available for these different AI projects. And they're usually separate from the data engineering part and the data integration part. We also, as the space is moving very fast, we need to be fairly agile, actually moving the data out and making it available for these projects. It doesn't make sense to spend a half a year getting the data out before we can start our AI project. This sort of the point is missed, and actually need to retool to a new product at the point of time. And then, as Stefan said, we need to multiple parallel solutions. So there might be one vendor that does really good fraud analysis, but that might not be the vendor that actually do really good sales analysis of sales predictions. So we need to have multiple different product stacks. At some point, maybe Microsoft might solve everything, or some other might solve everything, just have one AI, but I don't think that will happen like in the next 5-10 years. So we have multiple solutions running in parallel, and there might be some internal project as well that we need to cater for. So we actually can do the organization can do the value add internally because there is no commercially available solution. Then also one of the things that we're seeing that AI is popping up in unexpected places. So we can try to plan out where we need to deliver our data and what data we'll deliver, but then the salespeople come down. I want to have it on an iPad, on an island, in an air balloon. I don't know, but it makes sense for them and it creates value, right? So we need to be available and ready for supporting those cases. So this is sort of rewritten of the, not quite, but a bit rewritten of the access to data or the data in the data space. But what we need from the bottom up, we need our data, we need access to our data. We cannot do anything without our data. So we need the data out of the system. Then we need to ensure actually that the consumers have access to our data so they can use it the right place in the right time and in the right access scheme. When we have those in place, we actually need to ensure that we have our quality. AI does not work, machine learning does not work, or reporting as a whole doesn't work if you don't have high quality and confidence in the data. But especially in training data, it's really garbage in, garbage out. And the last part we need, once we have all those three in place, we need timeliness. And there's a duality to that from the perspective that we need to be fairly fast on actually delivering the data, but also once we are delivering the data, we need to continuously deliver it in a pace that actually the organization and the business need this data. So there might be some fraud detection. We really don't want to wait a week for that actually to run and detect that. We might ideally want to run it when an order is placed and pop it up and they can actually do anything and do something about it before the order is shipped. So there's different use cases that require different timeliness of data, and we need to support these different use cases. So yeah. I have it here. Sorry. So how do we actually solve that part of it and actually make our organization ready for supporting these different use cases? So if I actually go to the end of things, and if you can switch to the computer. So this is where everything ends up. It's Python. So when we're talking about doing custom AI, we end up doing Python stuff. There might be other solutions, but this is also a substitute for whatever custom system. So what we're actually doing here, we're actually getting data from our talent platform, from our Snowflake, and we can actually pull it directly into Python, into some data frames. I'm pulling some sales data, some custom data, and then I'm just counting it and actually doing some preview. So this is of course, then we have the rest of the machine learning model. We're not doing that here, but this is just showing this is what we actually want to end up. We want to end up high quality data available at the hands of the data engineers and the data scientists, accessible in their chosen platform and tool. So that's what we're trying to achieve here. So we can switch back. Cool, thanks. So if you look at the pyramid, so at the bottom, then we need to access our data. How can we actually get our data out? And when we look at the landscape at our customers and the business and in general, I think everybody knows this. But as we can see, of course, we have our relational databases. We have custom systems built on that, legacy system, new system. But also we see a lot of ERP systems and CRM systems that have special interfaces that we need to pull data out of. It's not we cannot access the database, or accessing the database does not make sense anymore because it's so highly technical and time-consuming. And of course, we have all our cloud systems that are wrapped in APIs and other interfaces that are not relational databases. So it's difficult to getting the data out. So we need to solve that. And then we also want to land the data in our data platform, and there might be multiple data platforms. We might need to have some cloud data warehouse for some purpose. We have some relational database, maybe to feed some custom APIs, and we have some data lakes for doing some of the unstructured data, or maybe for feeding our machine learning. So, getting back to the point why we are showing this is that, from our experience, like a lot of organizations spend a lot of time like trying to build their own access to all these systems, and it takes a lot of time, a lot of effort, and also a lot of knowledge. But the point being is there is actually a solution for most of the system in the market right now, where more or less can plug it in and move the data and be done with it. So that's actually what we are going to do a short demo about. We have set up a simple system for a substitute for an organization. So we have an Oracle database for an application database, and we have a Microsoft SQL database running in our Azure environment. They are actually moved to Snowflake. We have chosen that for the data platform. It could be Google, it could be whatever. It's just convenient for demoing it. So what we're going to show is just like how do we actually get the data moved to our Snowflake platform with some of these tools here. So if you can switch to the computer. So here we have a substitute planning system. It's actually Qlik Cloud actually, running with our Stretch's write-back solution. So this is a solution where actually Live can write back data back down to a database or data warehouse as you want. So this is our substitute input system, where we are going to do some data input. Then we have set up a pipeline. We have our on-premise database, and we're moving that to our Snowflake data warehouse. And you can actually see it's running, so there's a few seconds delays, but that's pretty good. And of course, we have our endpoint, where we actually have our data here, where we actually want to land our data. So if we go in here and do some changes. So now we're running live demos, so that's always interesting. So actually, if we go down here in the database, we're running here, that's our on-premise database directly, standard Microsoft SQL server. We can actually see we have our data here with the timestamp here. That fits very well. And I can see I've done some testing before that. But if you go over here in our data project, we can actually see it's still running as it should be. And if we go here, we should, if we are lucky, we have our data here. So in that between, I'm actually inputted the data, I actually landed the data available for analysis in our Snowflake data platform. The point being is, here is we don't necessarily need live data, but the point is we have the option of actually deploying it in an organization. So for use cases where we need it, we can actually support it. For use cases where we don't need it, we don't need to deploy it, but we have the option of it. It's built into the system that we actually can do that. Also, the other point is when we move data as they happen, we actually reduce the load on the system because they are streamed to the consuming platform. So we don't need to like do full loads of the systems anymore. Yeah, so, and of course we can just go just to verify. The last one we have 23 rows, we can just do it again. If we are lucky. We have 26 rows. So actually we move the data from our on-premise consuming data through our data lake warehouse to our Python code in like a few seconds. If you can switch back. Yeah, so I have my demo here. So the other part we have for actually we showed them move the data, and I actually showed I consumed the data, but like how did I actually consume the data, and why do we actually want to consume our data? So in organizations, as we can see, we have these multiple different platforms we actually have our data landed on for various reasons and of various good designs. It might be different organizations, different departments, and so on. What we want to do is actually we want to make that data available to the different products at the end. It might be Qlik, AutoML. It might be some Azure, Google, Amazon. It might be some custom code that actually we are running, or it might be a combination of all of those. So one of the things that we've seen there is a bit of a challenge actually accessing this data on an organization. How should we do it, and do we need to set up like a data mesh with APIs and all that stuff? But one of the things when we have, we go here. So what we will show here is that we can actually do are fairly simple. Like in a few seconds, we can actually do an API on top of our data with the Talent platform. So yeah, it's not the enterprise scale solution, but this is really good solution for many of the use cases, especially when you're doing like the first steps of developing data for your data, AI and machine learning models. You just need to have access to the data and give it to the data scientists so they actually can start working. That shouldn't be a barrier. So if we go to the computer. So here I'm in the Talent data inventory as part of the Qlik stack. We can actually see I have two data sets. I have a live customer, which is the set that Stefan will demo later, and I have the write back global sales live. That's actually our data we have just been writing. So we can actually go in here and just show how it's set up. It's fairly easy. It's basically just a select statement on the data warehouse that is connected. So that's how we select our data. That's fairly, so you need to set that up. And then actually we have, once you register your data, you have from the point of view, you have access to it, but also you can actually have some metadata about it. Stefan will touch a lot upon that a bit later. But the interesting thing here from our perspective is actually there's an API button here. So what we can do here is actually we can go in and see this data set I registered in my system in Snowflake. I want to expose that as an API. And that's what I'm running. So it's basically just move the data to Snowflake, register the data in Talent, and then just expose the data API and set up some data consumers. You can see we have here a data scientist developer as a consumer on it. And if you go here, see in the top here, we have the URLs, and we have the tokens for access. That's it. That's how we move data, like in a few minutes, from on-premise all the way to Python, and actually can start working with our data.
Do you want to clarify just how we get the data from the on-premise database and into?
Oh, yeah. Yeah, a bit. I think also you touch a bit upon it, but basically there's an on-premise gateway. There's a gateway running inside the system that facilitates the connection between the on-premise system and the infrastructure. So that actually does the connection to the SQL database, and it monitors, and then it will upload the data to the cloud as it changes in the system. And of course, if there are any questions, please ask them. So, yeah. Any questions to getting access? Yeah.
So on the source database that you have there, what kind of prerequisites needs to be in place there for this to work?
There's a few. The main thing for us, especially this, how can I say it? This platform or this technology stack use the transactional system in the databases. So what they need to have access to is basically the transaction log on the database, and then there's some various mechanisms in the database, like Microsoft. They have their own change data capture mechanisms that they are going into. You don't need to be DB owner. You can actually set it up without being a DB owner on the database, but so you need access to that, and you need the SQL agent running on it. And for the Microsoft SQL, you also need to have the logs running in some mode. But there's a very detailed description of what you actually need. We actually had a customer from running an Axe ERP system, and they were having issues that they couldn't move the data during the day because it would basically kill the system. We installed this system, and actually it was sort of like it went back like a week later. I can really not see that this is running on the system, and we were live streaming out orders of the system into the data warehouse. It was sort of like now you can do live analysis or like orders to the salespeople directly, and they didn't have to wait like 4 or 5 hours. So it's a pretty cool technology.
It's in everything that's relevant, you could say that it's basically a clientless or agentless kind of deployment towards, like the drivers exist on the gateway in this case, which acts as the data fetcher and the data pump. So it's pretty easy. It's based on a technology that came into Qlik with the acquisition of Attunity, which is replicating Compose. So it's the same kind of technology wrapped under like under a cloud structure instead. So it's pretty good because it's not noticeable if you set it up the right way.
Any other questions? Cool. I think we'll switch back. Yeah, have our demo here. So then actually we'll go into a bit about the quality part of it.
Yeah, exactly. And I mean, moving data from one place to another, it's easy, right? Or not. Anyways, what's more important and specific, I mean, because the goal here is to move data from one place to another to enable analytics and AI, ML, in this particular case, machine learning processes. And we need to be mindful about the quality of data. Crap in, crap out is absolutely something that comes into play here. Those of you who have worked with data modeling before, and specifically modeling for AI or ML processes, know this. That your drivers needs to be, like your key drivers needs to be really thought out. And they need to be of high quality to be able to function. Otherwise, it's just, you're not going to get the results that you expect. So what we want to try and enable is this thinking of promoting. I mean, this is not something that Qlik came up with, or me, or anyone else. It's just this is a fact of doing these things, that you promote data through the process of different layers where you either decorate it with other data, you increase the quality, you make sure that it's both secure but qualitative, and that you can trust it. You tag this in different ways. You probably catalog it for easy access to those consuming it. And eventually, at long last, you will arrive somewhere around here with a gold state data set. Probably a data mart somewhere, if you're doing the traditional way. That can then be used to be pushed out to consumed with analytics tools. But it takes quite a lot of effort to do this. Thank you. And I mean, yeah, sure, those of you who've done like Qlik scripting is like, yeah, just give me all the data, I'll take care of it. Yeah, sure, but what happens when the data changes? Like, you can actually do that in Qlik, you can have your metrics, you can do all the stuff that you do as a developer. But there needs to be something more to actually, make sure that you are in strict governance of this data, and that you can sit back and relax and say, okay, I actually have a process for this. And not only for this particular pipeline, but what we want to promote, and what I see when I start looking to build these kind of processes with talent, is that you want to build a framework that you can actually depend on in the organization. Not only for this particular piece of data set that we're doing here, but we're thinking larger, like I actually want to set a set of rules to how to qualify my data. And I want to work that into the organization. And if I do that, then I actually have my rule set. It's a documentation, it's going to live in there. So for the purpose of this demo, we're going to do something pretty simple, so to speak. We are going to skip the silver landing, we're just going to go straight fetching it from the source. We're going to put it in a kind of a bronze landing stage where we're going to do some light transformations. And then the next step over to gold is where we actually do the real heavy validation, because I know what I need to deliver to Michael. So with that in mind, I know exactly what I need to do with the data. So if we can switch to the computer, thanks, please. All right, so I'm gonna do what you always do. I'm gonna start out with refreshing all the windows, obviously, so the stuff doesn't time out too much. Close your eyes. And then I'm gonna do a little bit of a favorite here. I'm gonna do what users do best. I'm gonna destroy some data. So I'm gonna run a couple of updates here, which is basically going to just kill some email data in the database. Now, what I'm doing here is running a bunch of statements on the Oracle database in on-premise in our Azure cloud. Now, this is the source where we're actually getting the data. Again, this is a pretty slimmed down demo. It's based on the same stuff that Michael showed before. But what we've done here is actually deployed a pretty simple change data capture pipeline in Qlik Cloud Data Integration to pick up these changes, the delta changes, which you saw just came through. No, did it? They haven't really come through yet. So what it's going to do is basically take this data, pick it up. It's going to put it in the landing, then the storage task is going to kick off, and this data is eventually going to wind up in our Snowflake landing. Yeah? So somewhere here. So this is our data now, and in here lives both bad and good data, as you saw. That I actually destroyed some of this data. So we need to remedy this. Now, we're going to go back to Talent Cloud. Now, I think, so this could be a little bit confusing if you're not familiar with these tools. We're going to work primarily with Talent Cloud and Talent Studio. And the reason why I'm going to jump back and forwards between these two comes back to the whole thing of promoting data through the pipeline. And we're going to use Talent Cloud to actually put these kind of quality gates in place, and we're going to use the studio to build a pipeline or a job to actually process the whole thing, to move the data from one place to another. So the Talent Trust Score, if you haven't seen it before, is a metric on one piece or several pieces of your data. It's going to tell you how qualitative your data is, discoverability, completeness, popularity, validity, and so on. And this changes over time as the data gets updated. Now, Talent Cloud doesn't have all the data. It only has a meta set of it, basically a sample, a snapshot. But that is enough for us to know that, oh, we actually have almost 2% of faulty data in here. I can go down here and I can look at email. There's actually 3 data sets that have email in them. And I have some red here, which means that there's a bunch of values in here that's actually wrong, that actually doesn't qualify. They're not emails. And the reason why Talent know this is because this is like a semantic rule, meaning that this is a very kind of a pretty advanced regular expression that knows that this is what an email should look like. And if it doesn't, it's deemed red. I didn't do this, it's built in. It also figured out that, yeah, it's an email, this is PII, I need to be careful about this, so I'm going to tag it as such. So this gives you a pretty good overview of the data set. So this is my bronze data set, and this is registered from Snowflake. So this is the data that was actually brought in by the change data capture from Oracle into Snowflake, and that I can now see and work with in Talent. Oh. What did I tell you? There we go. Can you see it? Yes, you can. So this is my Talent data pipeline. We're going to do, it's pretty busy, so I'm going to walk you through this. This is pretty simple stuff, though. On the left-hand side, we have our Snowflake customer raw data, basically what's represented as the bronze data set. We are going to bring that into what's called a data preparation. Now, this is a block in the studio that basically only refers back to Talent Cloud. And when I say that, I mean this. So I've created a data preparation here in Talent, and basically this is just something that prepares the data as it moves through the pipeline. Now, this one is a very rudimentary one. You don't have to have it for everything. I did one. The only thing that it does, it has one step, and it deletes a column I don't need. That's the only thing it does. Yeah? It's an other email format field that I just don't want to have. So the resulting data set is going to look something like this. Okay, so when I run this, it's actually going to do that, and then send the data off to the next step, which is a data quality rule. Now, this is actually a block where I, again, go back to semantic rules in Talent, meaning that in a kind of a self-service fashion, that's why I'm going to move into data stewardship, you have something called semantic types and data quality rules. These semantic types are pre-created to allow you to classify and secure your data. They are meant to be applied on your data and will produce a certain outcome. They are paired with, for example, a valid email address rule that I've created. So this is applied on that quality block that I have in my pipeline here. Now we're going to run this, and a bunch of stuff is going to happen. So you can see that we have a fork in the road here. 2 things are going to happen. All the data that actually passes through validation, and that is deemed, yep, this is an email, is going to go into what's called a mapper with the accepted data. We're going to map that against the already existing schema, or a new one if you want to, in Snowflake, which is in the top right here, to my gold data mart. So that's where all the customer data that I have in this data set is going to wind up. Only valid data based on my rules. So what happens to the rest? Well, we put that in a separate track to rejected data. We put it in a table, and then we drop that, and we forget it, right? No. I mean, I still want to do something with this data. What I do, I can see the data here. Poor old Kenny here, he puts its name in all caps in the email instead, which is a bad mistake, a common one. But we have this data, so what do we do with it now? We pipe this into a data stewardship campaign. Again, this derives from the fact that we actually have something like that in talent. So I've set up a campaign, and data stewardship, for those of you who are not familiar with it, is a way for me to delegate tasks of cleaning up data. Large amount or small amount, doesn't really matter, but someone with subject matter expertise about the data itself. And I can say, you know, I'm going to give you a bunch of data that is wrong, and you can go and figure it out. Now, I conveniently pass this to myself because I don't trust Michael. So I'm going to get these tasks here. So when I log in as a steward in Talent Cloud, I can see that I have 4 tasks. And as the campaign is set up, I only have rights to do changes to particular fields. In this case here, well, I can't help Joseph, so I'm going to remove his field. Probably Linda just forgot the @ Kenny's gone, Marcus gone. I'm just going to mark all of those complete and do validate. Now my job is done. So what has happened now is that once this is done, we can trigger, I'm not going to do this here right now, but we can trigger another job that we've prepared here that looks something like this, where we actually pick this data up from the stewardship campaign because it's being logged internally in the talent data structures. We can pick that data in, and we can return it back to the gold mart once it's fixed. So all the data that we actually deemed as resolved, it's going to come back in there. And then you're going to ask, well, you just blanked out a bunch of fields. Well, that's fine, because null or blank is fine in this case, because I know that Michael can handle that. Wrong email addresses, on the other hand, is not. So all of these 4 rows is going to be published back into the gold data mart. And there it is. I mean, it's maybe I feel that it's simple, but it's pretty straightforward when you start thinking about it. So combining these 2 tools, the power of this, of the designer, not the designer, sorry, the studio of Talent, with the capabilities of the cloud one, and the QCDI of moving Delta in small batches from one place to another, gives us a pretty good control of this data that I want to deliver to him. And since this data now lives in Talent, and since it's also, if we're going to have a quiz, how is it represented? As a data set, what can I do with that? Like Michael showed before, I can automatically publish an API in here to give access to that data straight away when I'm done with it. Right? So I hope Michael's happy.
Yeah.
I think we can go back to the slides. Yeah, this is me again.
Yeah.
I'm going to take a sip of water.
Get the other machine.
All right, so we told you when we started the session that we were going to go backwards a little bit, and I think we've done that, which is why Michael started out with a window showing Python. So Jonathan probably had a minor heart attack when we started out with that, but I think he's fine now. The purpose here is that, yeah, you can start with the data, but sometimes you're just going to have to ask the people who actually work with the data, what do you need? And then back into the data. Like, they can be parallel processes for sure, but sometimes you're just going to have to start in that end. And one of the things that we talked about as at the top of the pyramid or the bottom, which way you want to look at it, is timeliness. And so we know, and we're seeing, that delegating these kind of tasks of managing data, fetching data, making quality of data is actually delegated to people, and then they don't want to spend time in running SQL queries if they don't absolutely have to. So a low-code, no-code kind of interface is actually something that's pretty popular, and it's coming along. And it makes life easy to drag and drop and to be able to design pipelines like this. But also, and this is, we know this, but we need to make sure that we have a set of connectors that is wide and capable enough to be able to bring in different sources and targets. Again, back to what Dan and the others have said, we cannot be locked into one specific tool or platform. It just doesn't work that way. You are going to limit yourself and your customers if that happens. Because you are going to see a mix of tools. People are going to choose their own tooling. They're going to have their allegiances to different vendors and technologies. They're going to have the history of where they worked before, and so on and so on. And you're going to see all these tools. Like dbt is super powerful, but it doesn't really have a UI built in. We want to be able to make transformations on this data. We want to merge data, decorate data, do all the kinds of stuff that we're used to. And we want to do it fast, because obviously when you talk about AI, ML, it needs to happen yesterday.
Yeah. And also, once we have done that and we're actually happy with what we got, we also need to keep in mind that actually we need to run this in production. So one of the things I've seen a lot around is like how do we actually monitor these pipelines, these quality pipelines, these data movement pipelines, and all this. I've seen a lot of custom code where I sort of like build it works, and then we like look at it when the business is complaining that the data is not updated, and we like try to track back with the code without comments, and that gets old fairly fast. So one of the things that is very imperative when we are building out these large models with a lot of consumers is actually that we have monitoring on our systems, so we know if everything is working as it should, or there's something that looks weird. Also, so we can catch it in time. It doesn't really make sense that like we load old data or bad data to our machine learning, and then we like burn $10,000 of compute cost on training a model. Sorry, the data was wrong. Let's just do it again. So monitoring is getting increasingly more important in this deployment. So that's one of the things that with these tools, once you set it up, they're built-in monitoring in this, and you can also hook in different APIs to your custom solutions. So if you want to hook it into doing ticketing and all the other stuff, and who should actually get notified, this is built into these tools. So that's one of the things also you need to keep in mind. One of the other things that is important is we need to make sure that actually can run these, don't necessarily not DevOps, but DevOps-like solutions where we actually can do in development, test out our integrations, test our data flows, test validation rules, test actually did we construct the data rules correctly, and do we catch what we are catching, and do we actually fix to what we do expected. Regex is like, can be complicated if you're going down that route. So it's nice to be able to test it, but also to validate against a production system. Is it actually an issue in the coding, or is it just because somebody chose to redesign the production system without telling us? It's nice to have a A and B comparison. So for that, we also need to make it possible to actually to move configurations between systems, and we also have possible with this. There's full, more or less full Git integration, so we actually can do version controlling of most of it, if not all. Then there's another really important point. Is like when we're running it, we actually had to pay for it. So it's nice, like it's real time, it's cool and everything, but like it costs a lot of money, and we might not need it. So an option where we actually can tune the different use cases, so we have a cost performance that makes sense for the organization. So for some organizations or some use cases, it might make sense to spend a lot of money, like for getting the data real time, because it like we can do fraud detection real time. That actually saves us more money than we burn. But from other use cases, like the CEO only looks at the report like every Friday, so why load the data faster than that? That doesn't make sense to have it like a 1 minute delay on that. So there's an increasingly option or requirement actually that we can tune the different solutions. And that's one of the things that we have with this, where we actually, for the cloud data integration, actually it's aware that when it's writing to Snowflake, for instance, it actually applies the data. You can actually tune how often it should apply the data, and then tune the cost that way. Yeah. So.
Yeah, exactly. And real time is one of those words that I, again, to Sebastian's big dismay, I don't really like. But near real time, or as close to real time as actually valuable for whoever's working with the data, is something that we also need to consider. We can't do full loads all the time. We need to be a little bit more snappy on our feet. So yeah, the timeliness is really important. And also this, I mean, even if we only have one source, we will never have only one target, never. You will never have one consumer or one target system, never. It's going to be a multitude of different storage platforms or consumers where you want to put the data, or APIs, like data scientists, like Michael and his Python scripts, obviously he wants to consume it via an API. Some other people want to use it in a pre-structured data set in a data warehouse, or they just want to have QED files in an analytics platform. Who knows? But you need to take this into account. And we're moving large amounts of data. Back to what Michael said about cost and performance tuning, to make sure that we don't have, an overabundance of ingress or egress costs when we move data in and out of cloud. That's been a big discussion a couple of years ago. Cloud costs, how does that relate to the historical way of treating data?
Yeah, and also add to the data, what we can see is that like for doing your machine learning model and AI correctly and with the highest fidelity, you actually need the lowest level of granularity. You cannot do the old tricks by aggregating on the source and then move the data. It doesn't really work that way anymore. It has been shown multiple times that you finer granularity you have in your data, you better the prediction of the model will be if the data is of good enough quality. So that's also one of the key drivers for like getting a massive amount of data out of the system. We need a lot of data, high granularity, and a lot of history to train our models. So, but the point at the end we come to like why I've shown some Python code that's pretty cool, but like that's cool for the data scientist. So like what can actually put into the organization? Where can we actually create value? How could that look? So that's we have created like an example here. If you combine Qlik and AutoML, some automations and some Python code in automations, what can we actually like build some as an example? So if you can switch to the computer. So we have created this churn dashboard. And if anybody has any questions, I have the guy who's built it here, so we can ask him. So what this does is actually it's a Qlik dashboard, fairly customized, and of course it is. You can just click on stuff, like I can do. But actually, we have loaded our data, and we're running it through our Qlik ML model, and we're actually predicting the churn risk of the different groups, and we're actually also classifying the customers into to different segments of where our risk of churning. So if you go here and select our bad customers or high-risk customers, I wouldn't say bad customers, high-risk customers, we can actually get a list of the different customers. We can actually see what they are the predicted churn risk. The thing we then can do, actually, we can go into here and do an analysis on what can we actually do to mitigate this. So when we just set up the configuration here, we have a tool where we actually can go in and see like what the boxes signify, how is this customer set up, what's the customer value, and what's the churn risk. And then we can go in and see like, okay, if we like do add some online security, our model predict actually that will reduce the churn risk, but of course it has some added cost for us. So we need to like, does that make sense, right? We can also maybe switch them to a 2-year plan that actually reduce the risk further. But that's sort of like I need to guess. But what we can do, and that's where the automation part with some Python comments, we actually do some optimization search with the AutoML. So right here we are running, asking the code to run through like, can you find a good solution for the customer where we actually can go in and configure it. Of course, this is a constructed data set, so it might not make sense in all instances, but it shows the point. So if you can actually convince the customer to go to a premium plan with a 2-year, actually increase the fee, and that's really the interesting part, and set it to, I don't know, some tech support. We actually get it, but I'm feeling a bit cheap. I don't want to give them the tech support or get them the promotion. Most of this got, but like 3%, that's good for me, for this customer. So we actually could go in and see actually what does our ML model actually predict when we do these changes to the customer, or it could be a customer segment as a whole. And then at the end we can do, as talked about earlier, actually we can do a native write-back, and we can trigger some other automations directly. That's Sebastian talked about. We can actually send an offer either directly to the customer, and we can send it into the customer operations pipeline, and they can actually go through and look at that. So this is an example of like, actually from this, just a second, from this perspective, we actually increased our revenue on the customer, and they should have a lower churn risk. That's interesting, right? Question?
Yes, how come you have chosen customer value and not customer lifetime value? Can we change it when you change the monthly fee?
Yeah, so that's a good discussion on like how do you actually see a customer, and it's also how is the acquisition costs and the churn costs added into this. So you're hitting one of the points that like how do you actually define customer value? That's one of the key issues we actually are having with deploying some of these, like the terminology doesn't always align with the different departments of the organization of like how do they actually see it and what is actually factored in, how to split the cost and in revenue. Because this also, like doing this process also costs something, and like spinning up a customer operation and actually talking to them also costs something. So it's a good point, yeah. it's more for show, but get an idea like what could you do in the organization. And it could be different stuff. It could be like orders, it could be shipping, it could be vendor selection, stuff like that. So I hope it makes sense that you can do, with the Qlik platform, we actually integrate it in and we actually do the different parts of it, where we actually move data into, train our model, and then we actually use the model in our dashboards, in the operation directly, and we can actually help the organization add value from our models. Cool, let's switch back. So yeah, that's sort of, any questions to that? Cool. Then I think, do we have anything else to add?
No, not really. I mean, yeah, it's a super cool demo. So,
yeah.
Questions?
Yeah, I have. Yeah, we're gonna end up with like one thing, and like one of the things that our main point for this is like we see a lot of like movement in the AI and ML space. We have said that a lot of times, but like a lot of the issues we are having with the customers and you specifically, maybe. No, is actually getting the data out to where it actually needs to be. And we have seen a lot of organizations like spending half a year like trying to figure out how do we actually get our data to our projects, like in a secure way. How do we secure it from GDPR perspective? How do we actually secure from access point of view? How do we actually move it and make sure that it's valid? And our point is just like there's a tool for that, and it's like not that expensive. You plug it into organization, and then you actually free your data, move it to your data platforms, whatever they are, and you actually get moving with deploying ML and AI. This shouldn't be the stopper of your organization adopting AI and ML in your organization. That's our main point. Like it's there and it's ready for you to use it. So.
Yeah, well said.
So, any questions now?
Oh, come on. Yeah, Morgan.
Hi, thanks. This is really awesome to see. So I work a lot with AI, and part of the pipeline that I think is a little bit missing here is the fact of feature engineering. So a lot of the data that comes through this data quality pipeline eventually comes to the landing target. Then we have to re-optimize that for the machine learning model. So what layer, if we remove Python from the equation, what layer would you put that in? And does feature engineering, in your opinion, go through the same data quality pipeline as you've set up from the extracted data?
Wow.
Yeah,
can I just thank you for pointing out flaws in the demo, Morgan. Great question, though. I really, yeah, because so I see some consultants working with AutoML. They prepare the last stages of the data set in Qlik itself, where a lot of the kind of, I mean, you can argue where it's best to do it, to be honest. Like, it depends on, yeah, that's a consultant word of the decade. Like, it depends, I guess. But you can do it pretty late in the stage if you want to. I guess it depends on your, like, maturity of how you make your data qualitative, right? If you have a governed pipeline or a process of getting data from A to B, you probably want to, depending on, like, you don't have to do like bronze, silver, gold all the way. If you don't, that's fine. Just, you need to put it in a place that makes sense for you. Like some scenarios, you get all the data through the same way in. In other scenarios, you actually decorate or merge data late in the pipeline. And it depends where the data comes from, I would say. I think that the need to understand what drivers in your data exist, that's more important. Like that's when that data actually comes into play or that's when you need to start thinking about, okay, so how do I actually, how do I transform this into something that's actually useful in an ML scenario? Yeah. Does that make sense?
Yes, it does. Thank you.
I can also add to, it's also like, where are you in the process? Like, are you starting out a new project? You might not want to put it into a pipeline. You actually want to keep it in Python or in Qlik. So actually get a feel for it and you can design it. And once you're actually happy with that and you sort of have that idea of like, this should be the shape of it, you can move it back to where it actually makes sense to have it we're holding back to the monitoring, like where does it actually make sense so I actually can monitor these features and actually make sure that they're not skewing over time, or that actually they do make sense. So depending on where you are, you should do it there where it makes sense, because Python does give you a lot of flexibility like to change it, but in production-wise, it wouldn't have it there, but probably move it back to the monitored part of the pipeline, somewhere that makes sense.
I mean, yeah, exactly. And I mean, who are you catering to? Like, you probably have different outputs that look differently based on what they want to do. Like an analytics guy, they can probably discard a lot of the data. They can do a lot of transformations. The Python guy too, just they do it in different ways. So talk to your organization and like set a common like understanding for what are we actually trying to do. And then we're back to starting in the wrong end of the process that we traditionally do. So.
Thanks.
I also have one more question. Is it also in Python that you choose which kind of machine learning model you will use? Decision tree, clustering, whatever?
If you're doing Python, yes. Then you're starting off with a blank canvas, and then you can do whatever you want. Also, the point for this demo is like if you can get it into Python, right, you can basically get it to whatever system. A lot of the commercially available system, you need to either to make it available like to an SQL query or some APIs, and then you can actually they will pull it into their environment and then build up and also actually do the feature detections and feature design in there. But if you're going to do like build your own, yeah, then you design it there. Hopefully you have in the organization you build up like a library of different models that works pretty well, but that's also some of the data scientists know. So yeah. Cool. So we can move data tomorrow for everybody?
Yeah, we're standing between them and lunch, so.
Yeah.
All right. Well, thank you.
Yeah.
Thank you, Michael and Stefan. It was really interesting. So if we can get slide, before we're going to lunch, not yet, 122. Yes, because before we're going to lunch, I want to welcome my great colleague Ellen, who has also been arranging all of this. So also a really big thanks to her for doing all this. But yeah, yep.
Thank you. Because Michael and Stefan were so quick, we went. Lunch is not ready, so instead we're going to do a quick interactive quiz where I will be including you guys. So how is all of these topics that we're talking about today affecting you guys? And I think this is a great gimmick for maybe have a conversation about how is AI affecting you in your organizations, or maybe you can take this conversation out of this conference room, out in the world, and maybe have some reflections about how this is affecting you. So I've made an interactive quiz which requires you to get your smartphones up and go to the webpage menti.com, as you can see on the top. So just maybe have 30 seconds for you to do that. When you've entered the page, you can go use the code up there, 5209 40, no, 24 37, 57, sorry. So the first question is, what new area of Qlik are you most excited about? And there's a few options, and you can see the results as I speak. So you see that it's shifting quite a bit as you're entering your thoughts. So mainly we can see that 14 at the moment. Let's see if it changes. I'm most excited about talent, data quality, which is also one of the topics we have had on the stage already. And right after that, it's going like this. And we have automated machine learning with AutoML, which is, of course, how AI is affecting data analytics and working with the analytics part of it and how it might be an outcome in the end. And I can also see that the rest is also something that you're eager to get working with. So yeah, does anyone feel comfortable in or need a few moments to get in their answers? No. We'll move on to the next question. Ooh, that was the last one. Okay, so how much do you think AI is going to impact your work within the next 5 years? So a lot of you already have said a substantial amount, which I think is quite fair because it's in between, it's like a gray zone. And many of you also feel like it's confident in like it's a complete game changer. And I feel like that too. AI has been rushed into my life within a year. For a year ago, didn't know what, not a year ago, maybe 1.5 years ago, I didn't know what ChatGPT was. But now it has been a complete game changer for me. I'm working with marketing, if you didn't know. So for my point of view, it's a complete game changer in getting your stuff done easily, or more easy. So let's move on. And I've noticed also that none of you said none to this question. So I think everyone feels like AI is going to have some kind of impact to them. So which aspect is the most important to you when it comes to dashboard designs? And this question might also be a little teaser for the next presentation we're going to have. Maybe you can see that one of the options is quite odd, but maybe we'll figure out why later on. Yeah. So this is just a guess for you, because we haven't heard about dashboards designs yet, which my colleague Jan is going to talk about after the lunch break. But for now, most of you think that context is the key and of importance for you when designing dashboards. So we'll see if you feel like the same after his presentation.
Maybe Jan can ask afterwards.
Yeah, and 3 of you thinks referencing Lincoln. We'll see about that. So how often are you using generative AI like ChatGPT, Insight Advisor, or similar in your workflow today? I can already see that many of you does it daily, but also some late adopters that never uses it, and some rarely. So I think this points towards a landscape where people are still adapting to these kind of new tools. Maybe they just need to get it going. Maybe you're not kind of fond of it. And I think it's interesting talking about so much about AI, ML, all these predictive tools and generative tools that some of you still doesn't use it that much, but maybe more on like a weekly basis. Yeah, and then we had all the questions, I think. No, one more. Which of these do you consider to be the most important aspects of modern data integration? maybe it's hard to choose because you might think that they are all important. Yeah, and maybe you've been infused by what Michael said just right before. But yeah, definitely data quality, tracking, and improvement is really important before real-time data streaming. And yeah, so working with the data and the integration, CDC streaming, is really important before moving into other aspects of data analysis and stuff. Yeah, so that was just a quick gimmick from me, and I think more or less lunch is ready.
Yes, it is.
Yeah, so thank you for participating.
Yeah, thank you, Ellen. So, lunch is served. Please be back at 12:45 for Jan, who's going to talk more about dashboards and user experience. Yes. See you soon.